and I'll ask again, can we look and listen here and not be chatting? With the non-right angle triangle stuff, we should be quite happy with finding the area of a triangle. And what was the thing that you had to remember when we're using this rule? Something about where your angles and where your lengths are. The lengths have to wrap around the angle. Excellent. Okay, so it's like 2 lengths and it has to be the angle in the middle. Are you happy? Do we have to do another example? I mean, it's there. You don't have to write it down, but let's just double check that we know what to do. So can we find the area of this rectangle? God, I'm on fine form. Can we find the area of this triangle? Absolutely, because we've got the 2 lengths wrapping around the angle. So we can just go straight into area is a half times. So you don't have to write it. I'm writing it. If you want to, it's all up to you. Times what? Yeah, times 11.7 times 8.4. If you wanted to write 8.4 and 11.7, go for it. And then we wanted to times that by sine. So make sure we're following the rule. We've got a couple now where it uses cosine and sine. So area, make sure that we've got it. Don't lose a mark by forgetting to put whatever those units are squared. Yeah? So we've got that under control. Remember, you're going to have a formula sheet. You can write this down, have an example. You've got the formula, all good. It's even given to you on a formula sheet. Then, if we didn't even have an angle, we could still work out that area using good old, who remembers the name? Heron. All right, this was Heron's rule. Good on you, Heron. Okay, and all we had to do was add up the 3 lengths, divide by 2. Did you want me to do one or not? No, I got one. I got a couple saying yes. All right, so we'd go S. First thing we had to do would find S, so that's just adding up your lengths. So 5 plus 6 plus 7. What do we have to divide by? It says 2. So we do that. What do we got? 11 plus 7, 18. Divided by 2 is 9. Right? And then your eyes go to this. So, you know, it looks yucky, but is it really? No. It's just saying, well, let's do the area. We're going to put in a nice big square root. What are we going to put first? Yes, bracket, and then it's just 9 take away all the length values. So it's 9 take 5 times 9 take x times 9 take 7. All groovy. Sweet? I think it's more an exercise in can you use your calculator? Quite simple. Right, then we went on and we used the cosine rule, and I came around just then. Fantastic use of the cosine rule, people, really good. But what was the thing again, Luke? What did we remember with the cosine? Same as the area that you just told me? It had to be 2 lengths and the angle in the middle. It had to be surrounding. Otherwise, you can't use your cosine, correct? So, what we now want to look at, we've got 3 things to do. The cosine rule, going backwards, and then your sine rule. And you've got 2 versions of your sine rule, and then we're done. All right, we just have to practice and do problem solving. So hopefully we can get the sine rule done by today, and next week we can just look at problem solving, tying it all together. That's week 6, looking at your test in week 7. 5, 6, sorry. Yeah. Sure. I put a list. Yeah, did that last time, do that this time. All right, so this time. Here's a typical example. This is in your book. They give you 3 lengths and they want you to find this angle. So, how do we do that? Well, they've given you these formulas, and I don't know why they've given you 3, but they've rearranged the formula for you. I can show you the algebra. Luke, did you want to see the algebra? Not today. I'll come and show you. Sit down and see it. So, the thing that we have to realize is if we're wanting the angle A, look where its opposite length is. It's the one that you subtract. Okay? So remember when we were finding the length of this, if we wanted this, we needed its opposite angle. Agreed? So now when we want the angle, right, the opposite length is the one that gets subtracted. I prefer to do the algebra, but I don't think you would. So we'll stick with this. So it means we take the other. So it's going to be cos theta. It's going to be the other 2 lengths. I don't care if it's 8 and 5 or 5 and 8, but it's going to be 8 squared plus 5 squared. Yeah? Minus, it has to be the one that is opposite the angle you want. So Sienna, I can see you're frowning. If I wanted this angle, then it would have to be that length squared minus the 5 squared. So it has to be the one that's opposite the angle that we want. Does that make sense? We'll do another question in a minute and hopefully that will put it all into perspective. Oh, why didn't that? Uh-oh. Now everything will disappear, will it? What did I do? Yeah. No. I will erase. Because that's just looking too confusing now. There we go. Right, so minus the 7 squared. And if I'm following this, what do you think I have to do now? Excellent. Divide 2 times what? 8 and 5, the 2 lengths that you had up the top there. Yeah? Now, you've got beautiful calculators. You can pop that in, but this will give you cos theta. Now, I don't want cos theta, I just want theta. Who remembers how to get rid of cosine? What is that called? Yeah? Cos to the minus 1, the inverse. That is right. So we're going to go theta, the inverse of all of that. Some of you like to use your answer button. Some of you like to just type in exactly what you see, your call. So let's see if you can use your calculators nicely. Can we get an answer for that? Okay, so we're carrying, I've got 60 if you use your calculator nicely. I feel a colour change coming on. I was thinking green. So, first thing that we notice, because I want this angle here, I'm looking that that is the opposite length. The 4 is the opposite length. You're right, Pip? Yeah? So, I'm going to go cos theta equals, I'm going to take the 2 lengths that wrap the angle, the 6 squared. All right, wrap the angle. Bless you. Cleo, you with me? So we take the 2 that wrap it, and then we have to subtract the length that is opposite. And then we just go 2 times 6 times 7. Does that make sense or not? Oh, Just a heads up. You shouldn't have to if he's used his fraction much. When I'm marking this, right, I am looking at this and I'm checking that you've got the 4 in the right spot and you've got your other numbers in the right spot. Because when I now do this on my calculator, I just go straight to theta equals. So I don't need to write more stuff down. If you really want to, and you want to write this, we'll go for it. But I'd like to think everybody knows by now, to get rid of a cosine, use shift cosine. So if you want to save yourself a line of writing, I'm okay with that. Just make sure that this line is perfect. Okay? So feel free now. I think you can try the next one by yourself. Yes? Do the second line instead of the first one. You want to go straight to this line? Yeah, look, as long as I've got one of either one of those, I'm happy. Sorry, we just said hopefully you've popped this rule in your note page. We are getting to the exciting point where we are coming to the end of just the rules. And then, I don't want to scare you too much. Yes, we have to do some worded questions, but hopefully we'll be good with that. All right. Now, before you madly copy this into your note page, we've got the sine rule. And you can see there's sort of a whole lot of stuff here. You will never, I repeat, you will never need all 3 pairs. So we can, oops, well that wasn't good. What did I just do? Oh no, what have I done? There we go. I'm back. I shook the cursor. Yep. Thank you. Now, when we talked about the cosine rule, you needed the 2 lengths and the angle in the middle, right? Wrapping around the angle. Luke, can you please listen here? Pop that down and just listen. With the cosine, 2 lengths, angle wrapping around, or you needed all 3 lengths. Now, with the sine rule, it's all about pairs. So it's not 2 lengths and the angle in the middle. You've got to have a known pair. What do I mean by that? We need an angle and its opposite length. And then one other bit of information. Okay? Notice with this triangle, we could not use the cosine rule, could we? We don't have 2 lengths for starters, right? And secondly, well, we don't have 3 lengths either, so no good. So it's got, well, we can't use the cosine. We need another rule. Now, why have we got 2? Well, it depends on what you're finding. If it is asking you to find an angle, so when we have, now, see, you put me off. When we want to find an angle, we'll use this rule. When we want to find an unknown length, we will use this one. Okay, so this one would be, we'll go blue, finding the angle. Angle question mark. We'd use this one when we're trying to find a length. So could you add this? You shouldn't have to draw the triangle again because you've already got that on your notes page. It's your non-right angle. But could you write these 2 rules, please? And then we're going to give it a dip on how we actually use it. And I think you'll see that it might be easier than the cosine rule. Just had a question. You know, we've got 2. Which one are we going to use? Well, I look at this question. Am I finding an angle or a length? A length. So I like to have my unknown upstairs, right? So A, stick it upstairs, all over. What does the rule say? How are A and big A connected? They are opposite, right? So A, what angle is opposite A? 47. So we're going to divide that by sine 47. So far, so good? Equals the pair that we know. Now, because we had the length upstairs on here, we have to have the length upstairs for the other. So it's going to be 5.6 over sine 29. That's it. So we'll do that again. You've got this pair here, A opposite sine 47. Yep. And then it's going to equal 5.6 over sine 29. And all you have to remember is if we're finding a length, they're both upstairs. Finding an angle, we pop them upstairs. But they've got to be the same on both sides. And now you have to rock your algebra. So I don't want A divided by sine 47. I just want A. So how do I get rid of a divide sine 47? Your times. So we're going to say, ha ha. Therefore, A is 5.6 over sine 29 times, and you know what? That's it. And that's exactly what goes into your calculator. And all they're going to do is just change your numbers from one question to the other. You should just see Cleo's face. I wish you could, because she doesn't like it. It's like this. We'll do another one, and then hopefully you'll like it. So pop that in your calculator and see what you get. Oops. So as we can see, we've got 11D. Go black. 11D1. Okay. So again, we go through this ritual because in your test it's not going to be, oh, hello, all these questions are cosine, all these questions are area, and all these questions are sine. So you've got to suss it. Yeah, but have a look. 1, it's not asking for area. So the sine rule for area and Heron's formula, not in the game. We're basically talking about cosine rule or sine rule. To find the length of the cosine rule, what do we need? 2 lengths and the angle in the middle. I've got 1 length. Oh, so cosine rule's out. Now that didn't take long, did it? So now we're down to sine rule. To use the sine rule, we need pairs. Have we got pairs happening? Yeah. We've got a pair here and we've got a pair there. Here a pair, there a pair. Everywhere a pair. And we go, oh, the unknown is a length, so it's going to start with x over sine of the opposite angle to x. What's the opposite angle to x? Yeah, we put equals the pair that we know. What's the pair that we know? So 23, and you just have to make sure that you don't say it's 23 over 37. Make sure it is sine 37. Okay, I have had students before say sine 23 over 37. Well, don't mix those up. Well, that's probably because they're chat. Okay, so now, how do I get rid of the divide sine 48? You times, right? What you have to concentrate is getting that first line. If you get that right, you get the correct pairs. Oh, good. So it's going to be very, very same, right? With, look at that, all of question 1. I don't want to ruin the surprise for you. Hello. All of question 1 is the same. Now, if you think, I want to practice this because I want to get it good on you, could you just look at question 2 for a minute? We have a problem, Houston, with question 2. Do we have a known pair? No. Oh, no. Oh, no, Charlie Brown. I've got a length, but I do not have its angle. Yes, Luke. You can figure out the other angle by taking the other 2 away. 180 degrees in a triangle. Yes. Wow. Even gives you the little hint. Okay, so 180, take that, gives you your angle, and then there's your pair. Okay, so practice a little bit with number 1. If you want to do them all, you can, minimum of 3 by yourself. Minimum 3. Go.